Find the area of the region inside of r equals 2 plus 2 cos theta and r equals 2 sine theta. So what we're going to do is we're going to just graph these two. You don't always have to do that, but I like to do that so you guys can see exactly what's going on with these two functions. It's kind of handy to be able to see what that looks like. Now I'm just going to go every pi quarters for these. There we go. And I'm just going to do the same for the other one. So now I'm just going to fill in the r values for the red one here, which is the 2 plus 2 cos theta. So I put all the values in for the first table. Now let's move on to the second table. So I have 0 in for theta, so that's going to give me 0 for r because the sine of 0 is 0. So then the next value is going to be 1.414, and then 2, and then 1.414, and then 0, and I'm just going to keep going. So now I'm going to graph the red one. That's 2 plus 2 cos theta. So now when we graph the 2 plus 2 cosine theta, we get this point here, and that's going to be 0, 4, and then I'm just going to keep putting them in. That's at pi fourths, and that'll be the one at pi, and then we have 3 pi fourths, and then pi, and then 5 pi fourths, and then 3 pi halves, and then 7 pi fourths, and then back to 2 pi, which brings me back to here at 4. So that's the first graph. So now I'm just going to fill it in. Now we don't always have to draw these graphs in here, but I just like to draw these in so you can see exactly what you're getting, exactly what you're computing when you get your answers. You kind of know exactly what they are and what they stand for. Now for the graph of the other one, it's a little easier. So again, I got the first point 0, 0, so it's there. And then pi fourths, 1.41 is there, and then pi halves and 2 is there, and then 3 pi fourths is 1.41 again on the other side, and then back to 0 again. So what I'm noticing here is we went back to 0 on this one, so here. And then if you notice, when I go to 5 pi fourths, 225 degrees, which would be in this direction in general, but it's negative, and it's negative 1.41, which takes me back to that point. So this actually graphs itself from 0 to pi. And another indicator here is that I have a 0 for my r here and then a 0 for my r here. And then the negatives right after that tell me I'm going back to the same place. So this is actually just a circle here. And again, we were starting at the pole. And that's our second one. That's our second equation, r equals 2 sine theta. So now what we're looking for, now remember what we're looking for, the area of the regions inside of both of these. So that means we're looking for that region there, because that's inside of both of those curves, and that's what we're looking for. So let's just try to figure out how we're going to do this. And this is the reason why drawing the picture is so helpful for these. Now, sometimes you don't have to put as many values as I have in there. I think for this one, it was actually pretty good. But I know some of them I'm overkill, and that's okay. You get a better understanding of what you're looking at, though, too. So anyways, that's what we're looking for. So let's see what we have to do now. So now think about what's going on here. So we would have to know this intersection and that intersection. So that's the first thing we're going to need to know. And then from there, we can actually build the rest of our integral. So let's start there. Let's try to find out where those two intersection points are at. So the way we do it is we take one of the functions, 2 plus 2 cosine theta, and assume that our r's are the same. So we're going to just say that now, since our r's are the same, this also means then the functions are the same, or are equal, I should say. I shouldn't say the same. That's a bad word that people use in English for math. So I should say that they're equal. Okay, so all I'm going to do now is solve for this equation and find theta. So the first thing I'm going to do here is move everything over, divide by 2. Let's start by dividing by 2 first. That's a good first step. So then I'm going to get a 1 here plus cosine theta equals sine of theta. So now one way to look at this equation, a simple way, is I know when this is 0, this is 1. So if I get 1 plus 0 here, that's going to be the same if this is 1 over here. So that's one way to look at it. So then I would say, what makes cosine 0 and sine 1? And one thing I can think of right away is pi halves. So pi halves makes cosine 0 and sine 1. Okay, now there's another instance here. Is there something that could make, and then we can think of, let's see, maybe this being -1 and this being 0. So I'm just thinking of variations of 1 and 0. So I can say -1, 0. I can say 0, 1. I can say -1, 0 here. And then I also can say, well, what's the other variation? One more. Okay, so there they are. Okay, now remember, I have to have equality here too. So that's the other thing. So if I plug in a -1 here, that's going to be 1 minus 1, which is going to give me 0 here on this side. And this is 0 over here. So that would work if I could find it. So now this one, if I made this 0, 1 plus 0 is going to be 1. So that would work too. And then the other two cases here, if I did a 1 plus 1 here, that's going to be 2 and then 0 over there. So that won't help. And then the last one here is a similar thing, because if I put a 0 in for cosine here, that's going to be 1 plus 0, which is +1. And then the other side I'll have a -1. So that won't work either. So I take those two cases away. So these two cases actually would result in legitimate answers if there were some theta that actually gave me those values. And there actually is. So the first one we came up with was this case here, where I had 0, 1, and that was actually pi halves, because that's where cosine is 0. Cosine of pi halves is 0, and sine of pi halves is 1. And the other one, where is cosine -1 at? And that case will also work, and that we know that's at pi. And then the sine of pi is actually 0. So those are the two values we're looking at. And there's another indicator too that I want to show you now. If we look at the original tables we set up here, notice this right here. They're the same point. And then also down here, those are also the same point. So notice the values we came up with down here, and then the values on the table, we see that they're exactly the same, which makes sense why we got what we got and the thought that we put into that. So now what we're going to do is, we know those values now. So we know this value here and this value down here. And now we have to think about our integrals now. Now keep in mind here, we're talking about building sectors here. And they're all starting from the origin. So for instance, let's say I'm starting from 0 here. So now when I do my mapping, my mapping's going to run around this way. Okay, so the idea then is, if I think about drawing sectors, that's what's going to happen there. But notice this, after I go past this pi halves here, notice what happens. If I keep on the same path, I'm actually outside of this function here. So that's a problem for us. So I have to now then say, okay, I got to stop there. So that's kind of the idea of what we have to do here. So what we're going to have to do is we're going to have to break this into 2 pieces. So I'm going to first have to calculate this here. And then after that, I'm going to have to calculate this piece. Okay, so that's the idea here. So now, essentially, I want to do this mapping first then. To there. So I'm going to run from 0 to pi over 2. And that's going to be, my boundary of that interval is only going to be this function right here. So that's the only thing stopping me from going further, or beyond it, I should say. Okay, so it's this function here is my boundary. So when I do set up that integral is then going to be from 0 to pi over 2. And then the function I'm looking at here, now remember how I set these up, 1/2, and then whatever function I have squared. So this will be the blue function. So this is going to be 2 sine theta, because that's the only thing stopping this one here. So that's going to be that piece. Now I have to come up with the other piece here. So now I'm going to start from there and go to the red graph, and I'm going to go all the way down to here, if you think about it. But when I go to here, pi, that is, that's 0. So I'm going from pi halves down to pi. So that's going to be the boundary for that one. So I said pi halves to pi, and don't forget your 1/2. And the function for that one is 2 plus 2 cosine theta squared d theta. So those are my 2 integrals that I'm going to have to add together to get an answer for the area inside both the regions together. So now for this one, I may ask you on a test to do something like this by hand. This wouldn't be out of the question. So we would have to know a few identities here. So the identities we need are these. So now I would use these, say for the first one here, that when I have this equals here, I get, so we get this when we simplify it. And one thing I want to point out here is, notice here I got a sine squared theta, and there's my sine squared theta there. So I'm going to sub this in its place. And then for the other one, I just have this cosine squared here that I'm going to substitute this in its place. So all the rest of these are going to work out okay. So this one's going to be an integral, that's going to be a separate integral, because again, I can split it across addition or subtraction. And that's where I'm actually just going to sub in for that piece there. So when I do that, I get this. So I actually get this as a simplification of the integrals above using this sine squared theta trig sub and the cosine squared theta trig sub. And one thing I'll just kind of show you here is for this one here, this 2 sine squared theta, I sub this in. Now think about this, if that's a 2 sine squared theta, that means I'm going to have this times 2 also, which means those are going to cancel. And that's why I end up with this down here. So hopefully that makes sense to you. And then for the other one, let's take a look at this one. So if you notice, the first two pieces stayed the same, which they should. There's no simplification I can do there. But then for this piece here, this 4 cosine squared theta actually results in this, and I'll show you how. So I'm really looking at 4 cosine squared theta. So that means I really have this times a 4. So what's going to happen, that 2 is going to cancel with that 4, and I'm going to have a 2 left over, and that's what we see here. And then times just the inside. And that's kind of what I did here on the inside there. So that's why you see that sort of simplification there. Now what I'm going to do is I'm just going to put the answer in here for you. But again, you would definitely have to do these by hand if I give you something like this. And that's very well doable here with this one. Okay. So the final answer then is 7 pi over 2 minus 8. So that'll be the final answer. And again, keep in mind here, this said find the area of the region inside of R equaling 2 plus 2 cos theta and R equaling 2 sine theta. So it has to be inside of both of those. So that's why I just have this little piece in here. That's why I get that, because that's the only part that's inside of both of those interiors. So there's our final answer for this one.